you. Today we are going to start with quadratic equations. That is ax square plus bx plus c equals to 0. Now what we are going to do today? Today we are going to find out the values of x. How to find out the values of x, because this equation is different type of equations which has got the power 2, that is the variable has got the power 2. Till now we have done about the linear equations in one variable, in which we can find out the value of x in a very simple method, which we can easily find out the value of x. We don't have to do anything. What we have to do is bring all the variables on one side and the constant on the other side, and thereby we can easily find out by just a simple method of with the addition and subtraction or multiplications of the variables, and then we find out the x equals to the result. Now suppose this also what we have studied, we try to find out the values in the same way. We are trying to find out the values in the way which we found the values of x in the linear equations. So we will see what all problems are we facing. Are we able to find out the values in that way or not? So and after that, what all shortcomings we are having there, then we will sort out those shortcomings, and then we will proceed with the real roots of the quadratic equations. It's very clear that we won't be able to get answer with the help of the linear equation. Then why are we doing in that way? We are doing in linear equations so that we can understand what we have learned. So what is the problem due to which we are unable to find out the values of quadratic equations, and so accordingly we will try to adopt some other method for solving. Now see, ax square plus bx plus c equals to 0. Now here if we want to find out by simple method, which is actually not possible, but just to show that we are unable to find with the help of this method, so we are adopting the quadratic. Now here what I have done, I have taken this x common, then here it is ax plus b equals to minus c. Now here x equals to minus c upon ax plus b. Now this is not the value of x, because x is also here on the right hand side, x is also here on the left hand side. Means this we have not found the values of x. Not found. This actually what we have done on the basis of the linear equations, we tried finding but we could not find. So what now after on the basis of the things which we have done, what we conclude? We conclude that x should be at one place. Number one, because x is at two different places, we are unable to find out the value of x. Now suppose the same equation would have been like this: ax square plus c equals to 0. This is also quadratic, equals to minus c, and x square equals to minus c upon a, and x equals to root under minus c upon a. But due to the presence of that x, this term, we are unable to find out the value of x. So when we try, suppose we don't know the quadratic formula, so when we try to find out the values of this particular term, we will keep in mind that the x should be at one place. X should be at one place. Right, this is the thing which we got from the whole of these calculations, which we saw just to find out the problem. Now how to put x at one place? If you see this expression carefully, then you can say that this is x square bx plus c. If you remember one formula, a plus b whole square, here we have a square plus 2ab and plus b square. Now suppose in place of xa, we write here x plus b whole square equals to x square plus 2xb plus b square. Same we are seeing here, x means we can, if we can convert this particular expression in the form a plus b whole square. This can be converted in a plus b whole square. Now how we are going to convert in a plus b whole square? For this we have to make certain changes in the expression, but keep in mind, if you make any change in the expression, the ultimate value of this expression should not change. Means you, in any equations you cannot alter the left hand side and the right hand side value. You cannot change. You can add, you can subtract, you can multiply, you can divide. The condition is the ultimate value should not change. Now here we have to convert in the form x plus constant whole square. So what we are doing here, in this x square is only there, so we have to remove this. We don't need this a. So for removing this, what we are doing here, ax square plus bx plus c equals to 0 whole divided by a. Now why we are whole dividing it by a? We are dividing it by a so that this a can be removed and we can be able to write in this particular form, so that again we can write in x plus one constant form. Get it? So that is why we are doing in that way. Now see, if you divide, then we will get here x square plus b by a x plus c upon a equals to 0. Now see here, we have got x square term, we have got here x square, but 2ab, now we will write here x square plus 2a is this one, x plus 2x b upon a. Now this is the term we are writing here 2 because we need 2ab. Now since we are writing there 2, and if we don't write 2 here, the value will change. So now if we are multiplying, then we have to divide also by 2, so that the value of this whole of the expression doesn't change. If I cancel both, we will again get x into b by a. But then why we have in this one? We have done this so that it can be written in this form 2ab. That is the main reason behind writing that. Now plus. Now we have written this is b term, b. Then b square is also there. Then b by 2a whole square minus b by 2a whole square plus c upon a equals to 0. Now the question arises from where this term has come. Why we are writing b by 2a ka whole square? We are writing, some of you must have understood, because we have to bring in this form. But ultimately if you see here, the value does not change. We are writing b upon 2a whole square, then again I am doing the subtraction of that value, then the ultimate result is 0. So then ultimate result is 0, but we need to bring these 3 terms. For bringing these 3 terms, so that I can write in this way, this form, I have written this form. Now a square plus 2ab plus b square can be written x plus b is here, b upon 2a whole square equals to, this will go that side both. This will become minus, this will be plus. That is b upon 2a ka whole square minus c upon a. This can further be simplified like b square by 4a square minus 4ac. This you have understood. I have taken LCM 4a square. This is b square by 4a square. The 4a square is the LCM. So this will be b square minus 4a is here. A square got cancelled. 4ac. Now again it can be written x plus b by 2a equals to whole root b square minus 4ac upon 4a square this can be written as root b square minus 4ac upon 2a. Now this can be written plus minus. Why we write plus minus? Because if plus 1 is there, then when it goes inside, plus 1 whole square. Like if we write here root under something plus 1, then it means plus 1 whole square. If we write minus 1, then minus 1 whole square. Means minus sign is there, it can be minus 1 will also be there, then also it becomes positive. Plus 1 is there, then also it becomes positive. So here the values can be plus and minus both. Now here what we have got here, we have found the square root of a 2 and a it has come. Now x equals to, this will go on right hand side, minus b upon 2a plus minus root under b square minus 4ac upon 2a. Now here the LCM is same, so we can write here 2a, this is minus b, this is plus minus root under b square minus 4ac. And these are the two values. X values are, what are the x values? X equals to minus b plus root under b square minus 4ac upon 2a and minus b minus root under square minus 4ac upon 2a. This is called alpha, this one is called beta. This term is called is denoted by d, which is called discriminant. Now now alpha plus beta, when we add, then we get certain value. When we do alpha into beta, then we get certain values. Those values also we will learn. Those values we will learn in the next class. Now here also, the discriminant is the major factor which determines the nature of the x, nature of roots we say. Here the roots, you know the root of a plant, you know very well. Roots, nature means nature, the root is real, roots are equal, roots are imaginary. Imaginary root means if it is root under minus 1, then root under minus 1, that is called imaginary roots. So how it comes imaginary, how it becomes real, how the roots are equal, all those things we will study in the next class. I hope this is very clear to all of you. Just have a look, and if you have got any doubt, you can ask me. And just ask me the queries if you have got any related to these any of the terms. I hope it's very clear. Only you have to keep one thing in mind, that we need to convert this ax square plus bx plus c equals to 0 in a plus b whole square. Now for converting in a plus b whole square, we have to do certain changes in the expression. We have divided it by a. The reason behind dividing it by a is to remove this a so that it can be brought in the form x square. And then we have added here 2 in order to make it in a form 2ab. Then y base could be by 2a whole square minus this we have done, so that it can be 3 terms of a plus b whole square can be brought. Now since we have added here b by 2a square, then we have 2a whole square minus b by 2a whole square. The reason being, you cannot add, you cannot subtract anything in any of the equations on your own. If you are adding, multiplying, subtracting, you have to neutralize those values so that the ultimate value, the ultimate result of this expression remain changed. Now just go through that, through the whole of the equations. If you have any doubt, you can ask me. Okay, thank you.